Yes, so let's start our today's class. This is lecture 16 on computer networks, and in the previous lecture we have started routing table. I have told you that how routing table look like. That was the aim of today's lecture. So let me tell you how this routing table look like. Okay, so we will start from the basics. Okay, we will start with that how exactly this come into the picture and how the things goes on and how the innovations were done. So let me start from the basics. Okay, so initially, okay, let me tell you, initially when routing table was developed, so at that time, let me draw a diagram so that you get more clarity. So A is connected to one network. Okay, so in this network A is there, and here this network is connected with R1. Okay, so I think you might get confused here, so better is I will make network like this, and this is computer A. Okay, this network is connected with router R1, and then we have another network, and then router R2, and then we have another network. In that network we have B. Okay, so now let us suppose A want to send message to B. So how routing table of A look like, let me tell you that. So initially when internet was developed, we have say two columns, destination and root. Destination and root. So A want to send message to B, so destination will be B in the routing table, I'm telling you, and in routing table there will be many entries. I'm just showing you one entry because I'm assuming that A want to send message to B. So there might be other computers also, C, D, E, F, and so on in this network. In this network might be many computers, in this also many computers, and so on. So for all of them, they, this computer will make entry. Okay, so I have told you, router as well as computer both have routing table. So it will make an entry here for B. I'm just assuming that B is there. Okay, yeah. So only one entry I'm showing you just for the simplicity. Otherwise, I have to make a very big table. So destination is B, and root will be, first of all, yeah, packet will go to R1, then it will go to R2, and then it will go to B, like this. So this is the content of routing table for A. Now, what about routing table of R1? For routing table of R1, I will copy paste it. Okay. Yeah, so let me shorten it up if I'm able to do it. Oops. Okay, so I will make arrow here, okay, just to save the time. So R1 table will be destination is B, root will be what? R2 and then B. Okay, and for R2 table will be destination B, root will be directly B. Okay, so there is no other router or something like that. So it is just like this only. Okay, so I think you have got it, na? Let me short it. Yes, so initially we have root method. This is known as root method. So that means entire root was there in the routing table. Okay, so A will make entry if destination is B, like that there will be many destinations, and routing table will cut an entire route. That means R1, then R2, then B. So it's just like that you want to go from Delhi to Bombay, then in your mind you have entire route. Okay, so that is the basic scenario. This is the route method. So obviously, is it feasible now? No, not at all, because there will be many entries. Okay, so let me do it roughly. 2 power 32 total IP addresses are possible. So 2 power 32, that means 4 billion entries you have to make, and for each entry you have to show the route also. That is impossible. Okay, so now as the advancements were done, next method is, let me jump to the next slide. Take snapshot.
Done, sir.
Okay, so I will copy this slide only, duplicate. Now I will say next method was next hop method. Next hop method. Okay, so for example, you want to go from Delhi to US. So you will board the flight for say Dubai, and then from Dubai you will go to US. So entire route is not in your mind. You are just keeping next hop. What is the next hop? Next hop is Dubai. That is the basic scenario here. So here, if destination is B, so you will keep next hop only. Next hop, that is R1. That's it. Okay, if destination is B, next hop is R1. Now it's responsibility of R1 how it will forward the packet and so on. That is the better method. Now, why you want to keep entire thing in your table? Okay, so here we will say next hop will be R2. Okay, and here next hop will be nothing. Okay, so next hop, in next hop I will put dash. Next hop is dash. Nothing is there. Why? Because now it is directly connected to B. Now that's why. Okay, so in this network is there. Yeah. So this is next hop method. So it is much more advanced method than the first root method. Root method was really worst. Then few advancements were made. Then we got next hop method. Okay, now but still the problem is same. No doubt now entry size has been decreased. Next hop is only one IP address, but previously there were many IP addresses, but still problem persists. That is 2 power 32 entries, and managing these entries is very difficult. 4 billion entries you have to manage. That is very difficult, and each and every router will have these entries, and each and every computer also has these entries. That is not possible. So next advancement was made. Take the snapshot. I will jump to the next slide.
So
yeah,
as in the previous example, like we knew that destination is B, and we wrote the route also B for the router 2. So why are we not writing so? When we know that case the destination is B itself, why do we give that?
So next hop means you can say next milestone. Next is B only. B itself is there, so we will not keep next hop as B. Next hop B means from B you want to go to somewhere else.
Okay, it means that like reaching B next hop.
So if you want to reach B, what is the next milestone or next hop? Nobody is there. You will reach directly.
Yes, sir. Yes, sir. Understood now, sir.
Okay. So take the snapshot. I will jump to the next slide.
Answer.
Okay. So I will duplicate it. So now next method was network specific method. Next hop method is not so beautiful. It was beautiful, but it is not so beautiful because 4 billion entries is not possible. So next came network specific method. Network specific method. Okay. So in network specific method, what we will say. So if R1, then we have R2, and then here rather I for simplicity I will make only one network. Okay, yeah, R1, and then we have a very big network here, and say this network is N1, and here we have computer C, D, E. Okay, yeah, so A will make entry. If we use next hop method, A will make entry for C, D, and E. Okay, and next hop will be R1, R1, R1. So this is mixture. Now forget about root method. Root method is not used. So better is next hop method. So I am advancing this next hop method to network specific method. So I will say destination is either C, D, or E. Next hop will be R1. So you will make 3 entries. But if we see carefully, I have told you many times in the previous lectures also that what we do in routing table, we have net ID. We are not keeping the host ID because it will simply increase the number of entries. Okay, so better is you keep net ID. So now we are not using this. Okay, I think it is creating some problem. Are you facing this? These are getting blur.
Yes, sir.
So I do not know why it is happening. Okay, so let me cut this out. So now what we want, so A will make, this is next hop method. This is according to next hop method, but now I am showing you network specific method. So now computer A will make only one entry, that is destination N1, and next hop is R1. Only one entry. So if there were 1000 computers here, so you will make only one entry, that is for net ID. Okay, I have told you when I was discussing about IP addressing and net ID and so on, I have told you this. Okay, so this is according to network specific method, so it is much more advanced version. Okay, but still there is a problem. There are many networks in internet now. So how many networks you will keep? That is a very big problem. Okay, so next came the default method which entirely changed the scenario. Let me tell you that. Take the snapshot.
Done, sir.
So I will copy this. Next is default method. Default method. Okay, so I will say, let us suppose I make another router, say R2. Okay, and R2 is connecting this LAN with entire internet. So I will call R2 as, I have told you in the previous lecture, default router. Okay, we call R2 as default router. So now what I will say, destination. So R1, R1 and R2. So if destination is N1, next hop is R1. If destination is any other, I will write here any other, then router is R2, or next hop is R2. That's it. So only 2 entry. This is the beauty. This computer is having only 2 entry. If destination is N1, then next hop is R1. If destination is any other, that means except N1, if any other, then I will go to R2 and it will forward the packet to entire internet. That is the beauty. See this. So in network specific method, I have to keep entry for all the networks. That is not possible. Okay, so we are using this. So what is this any other? Mathematically, how we will solve it, don't worry, I will tell you about it later. But the basic fact is like this we will do. So this is known as next hop method, and it was one of the best method, even which is used nowadays. Okay, it is used nowadays also. I do not know why this software is behaving like that. So let me just quit it and again start it. Yeah, so now I think it's okay. Yes, it's okay now. Yes. Okay, so I hope you have got it. So this is known as default method. Okay, so now we are going to use this method only, and now I will tell you that how routing table is constructed. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so now these questions have been asked in Git many times. Okay, so let me tell you that. So here we have a router R1. Here we have a router R1. I'm labeling it as R1. So now it is having suppose 4 ports. Okay, so with each port one network is connected. For example, here we have one network, say 201.4.16.0/22. /22 means classless. Mostly classless addressing is used. Okay, so question in GATE exam will be from classless only. But if this slash is missing, you will say okay, it is classful. Okay, I have told you many times. Okay, and next is 180.70.65.128/26. Next is 201.4.22.0.24. And the next is 180.70.65.192/27. Okay, so now these are the ports. For example, I label them as port number 1, port number 2, port number 3, port number 4. This is a scenario, and this LAN is connected with another router, and this router connects it to the rest of the internet. Okay, so this is the exact scenario. Now you have to understand one thing, and that is very beautiful thing. This router has 4 ports. So 4 port means this router will have 4 IP addresses. Generally computer have 1 IP addresses, but number of IP addresses given to router are equal to number of ports. Like if router has 10 ports, then with each port it will have 1 IP address. And for example, here with port number 1, this entire network is connected. So this network, okay, so from this network only I will take 1 IP address and I will give it to R1. Okay, for example, I have given 180.70.65.135/26. This is the address which is given to this port. Okay, what do you think? What do you think? Why we have given this IP address to this router for port number 1? Because if in this network any computer wants to send data to any other computer, and if it wants to R1, then these computers in this network must have a feeling that this router is nothing but our part only, or this router is in our network only. So that's why from this network I have given this IP address. Why? Because if they know the IP address of the router, they will give this to ARP, and ARP will find the physical address of this router, and then frame can be transferred and so on. Now how each and every computer will identify that this router is in our network? So they will apply this networks 26/26 with this, and they will find the net ID. Net ID will be this only. So in this way they will come to know that okay, this router is nothing but it is in our network only. That's why we can send a packet to it and so on. Are you getting it? In the previous lecture itself we have shown now that A will think that B is in my network, B will think A is in my network, and so on. So here these computers will think that this router is our part, or it is in our network only. Why? Because they will apply this 26 ones. Okay, and this 26 one will be ended with this to get the net ID, and net ID will be this only. You can check it out yourself. Okay, so so all the computers in this network will think that this router is our part. Okay, that's why with port number 1 I have given this IP address, or you can give any IP address from this network only. That is the basic thing. Now at port number 2, from this network I will give one IP address here. So for example, I give here randomly, I will take 201.4.16.2/22. This IP address is given to this router R1 to port number 2. Okay, now port number 3, let us suppose I gave here from this network I will give, so 180.70.65.194/27. Okay, and from here I will take say 201.4.22/3.3/24. Okay, yes, so these are the IP addresses given to the each port of the router. This is given in your question. They will give all this thing in the question itself, and they will say now construct routing table. Okay, I will tell you that also, don't worry. Okay, so now to this say for example this is port number 1, and I will give IP address to this port from this network. So let us suppose I take 180.70.65.200/27. randomly I am taking. Okay, and this is the solved example of your Forozen book. Okay, I am solving that only. Yes, so this is this IP address is given to port number 1 of this router. Okay, and this is connected to internet. So from internet you will get one IP address here. Don't worry about it. You can take any IP address. That it does not matter to me. Okay, so now I will construct routing table of this router R1. So let me construct that. Okay. So first of all, you should know this routing table will have total 4 columns. First is mask. Next is a network address or net ID. Whatever way you want, you can write. Network address. Then next hop. Okay. And the last is interface or port. Port or interface. Port/interface. Okay, whatever name they want, they can give you. Okay. So now we will make entry in such a way. Okay, so now there are choices to you. Okay, so you can make entry for this network, for this, whatever way you want you can do. But the basic idea is you should keep the mask in decreasing order. Okay, so this is known as longest mask matching. Longest mask matching. Okay, that is the basic rule which you have to follow. Longest mask matching means keep net mask in decreasing order. keep net mask in decreasing order. So what is the largest net mask? Slash 27. So first of all, I will keep slash 27. Power supply has gone. I am audible to you?
Yes, sir. Yes, sir.
Okay, screen is visible, na?
हाँ sir, हाँ sir.
Actually, I am not able to write. Let me check it out first. No, power supply is gone. Yeah, now it's okay. Yeah, so first of all we will take slash 27. Why? Because it was having largest number of one. I have told you na, keep net mask in decreasing order. So slash 27 I will keep. And what is the net ID? 180 70 180 70 65 192. Okay, and what is the next hop? What is the next hop? This router is connected to this network directly, so next hop will be dash. Port or interface number 3. Okay, next entry, very simple. Now it's very simple. Okay, next is slash 26. This was the largest, second largest, so I will keep 180 70 65 128. Next hop is dash, and port is 1. Next is slash 24 201422.0 slash 24. Sorry, only this 0. Next hop is dash, and port is 4. Okay, next is slash 22 201416.0. Next hop is nothing, and the port is 2. Okay, yeah, and now important part will come. I have told you na any other. See this, I have told you na here any other. So now I will tell you mathematically how you will represent it. So for mathematically, I will keep net mask as slash 0. So obviously when I keep slash 0, that means what? I will end with all the zeros. So after ending with all the zeros, what net mask I will get? All zeros only. Okay, so in that scenario, next hop is this network only. Okay, this network, and batteries, the IP address given to this port, that is this one. So I will keep here 180. Next hop is 180 70 65 200. Okay, and the port or interface is number 3. Okay, yes. So now I will tell you the working, how this routing table will work. First of all, I have just given you the idea that how you will fill the routing table. Now I will tell you the working. Okay, for example, this router R1, this is same questions have been asked. First is table construction. Table construction means they will just keep one entry blank and they will ask you to fill the entry, or they will expect you to fill the entry there. Okay, that is one type of question.
A port interface 3.
Fourth interface.
Port interface, like the last we wrote 3 now, sir.
3 because from here itself it will be forwarded na, because you want to put send the packet here to this router, and this router will send it to internet. Okay, so if R1 to R1, if these 4 are the networks, then it's okay. If there is some other network, or if packet belong to some other network, that will be just that will be in internet. So if it is in internet, then this router duty is to forward the packet to this router. Now this router, that is R2 will forward to the internet, na? So we have to put the packet, send the packet to R2. So to send packet to R2, from which port you should forward the packet? 3.
Yes, sir.
Okay, that's why we have keep it 3 here. Okay, so now I will tell you that how these you can say packets are forwarded. So type of question, let me tell you that first. Okay, so let me jump to the next slide. In the next slide, I will tell you type of questions. Which type of questions will be asked from this topic? Type of question. First is table fill. They will expect you to fill the table. Keep 2-3 blank entries, you have to fill them. Next is forward the packet. That means from which port packet will be forwarded. So let me tell you that. forward packet. So for example, let us suppose packet with IP address. Okay, here itself I will write, say 180.70.65.250. Packet with this IP address arrives at the router. What it will do? Okay, so what it will do? Now I have to toggle. So let me write it here. 180.70.65. What I have written? 250. 250. So this IP address packet comes at this router. So what it will apply? First of all, it will apply this net mask /27. /27 means 255.255.255. Three ones will be there, na? It will be 192 plus 32. No, 224. Okay. So what net ID you will get? 180.70.65.224. Any doubt here?
No, sir.
So why? How I have done it very fastly? Because 250 is we have done it, and simply we are doing ending. So 180.70.65.224. Please match it. 180.70.65.192 is there. So it is not matching. So I will not forward it from port number 3. Now I will try to apply 26/26. Okay. So next is, so hit and trial. Okay. 180.70.65.250. So next is 255.255.255. /26 means 192.
Okay.
So answer will be 180.70.65. 192 first two are ones. Okay, and here in 250, first two are also one. So we will get 192.
Sir.
Okay, yes. So finally, we are here also no matching. Okay, because network address should be 180.70.65.192. I am getting, but here it is 128. So it is not matching. Okay. Now there is no question of matching with this and this. Why? Because here we have 201 and here we have 180. So why you are applying /24 or why you are applying /22? It is just wastage of time. Are you getting it? So now finally I will apply this /0. /0 means 180.70.65.250 0.0.0.0. /0 means what? 0 ones are there, so all will be zeros. So after doing and, what you will get? 0.0.0.0. For sure you will get it. So that means this will be matching. The moment you get a matching, next stop will be this, and port and you will forward it with port number 3. So you will forward the packet here and it will forward it to the rest of the internet and so on. Okay, this is the way of forwarding the packet. Yes, any doubt here?
No, sir. As internet router is connected to port number 3, that's why it goes to port number 3.
Yeah, it will go to port number 3 and then it will be forwarded. So now you have got the idea of any other, how you will keep any other. So this is the very beauty of the mathematics, that you will keep /0. That the moment you keep /0, that is 100% sure matching will be done. Whatever IP address you put here, it will be matched with 0.0.0.0. Whatever you put here, it hardly matters to me, because at below everything is 0. So final answer will be 0 only.
Yes, sir.
Okay. So this is the beauty here. Okay, yeah. So what we have used, longest mask matching. That means keep net mask in decreasing order. Now, what if you keep them in increasing order? Now, please tell me, what if you keep it in increasing order? Okay, so there will be a very big problem which we have to face. Okay, so for example, if I take IP address as say 180.70.65.200, if this is the IP address. Okay, so R1 has received an IP address this, a packet with IP address this. So where it will be forwarded? So first of all, you will apply /27. /27 means 255.255.255.224. Okay, Yes, so it will be 180.70.65.192. You can check it out yourself. 2 to 4 means first 3 are 1, in 200 first 2 are 1. So first 2 ones, here also first 2 are 1s. So it will be 192. Any doubt here?
No, sir.
Okay, very good. So finally we have got it. So this is the net ID, this only. Matching is there now. So you will forward the packet with port number 3. So here in this network, you will forward the packet. So it is very easy now. So now I think you have got the idea that how we will forward the packet. But if in reverse order you keep it. Okay, yeah, actually here there will be no problem because port number 3 only. Let me take this.
Reverse order only, no, sir. Now.
Yeah, please come again.
180.70.65.200 which you took just now, it is to show in the reverse order only now.
No, I just want to give you more clarity. I will take one more example so that you get more clarity. Here also a packet will be forwarded with port number 3 only. Okay, so there is no doubt here because this is port number 3 only. Let me take another IP address. Let us suppose I take 201.4.22.5. Okay, so where it will be forwarded? So I will not apply this by common sense. I will say because here /27, but here 180, here 201. So I will apply it directly /24. /24 means 255.255.255.0, but you will get 201.4.22.0, and this is nothing but this only. So with port number 4 it will be forwarded. So here packet will be forwarded. Okay, so now assume that if you keep everything in reverse, that means first you keep /0, then /22, then 24, 26, 27. If you keep this, then obviously router will match with /0 first, and everything will be matched, and everything will be forwarded to port number 3. That is the biggest problem here. Are you getting it? Okay, so that's why we are keeping in decreasing order. This is known as longest mask matching. That means keep net mask in decreasing order. Now beauty is this, in GATE exam they will try to play tricks. What tricks they will apply? They will keep them. They will keep in increasing order. Okay, it hardly matters. Whatever they want, they can keep, but you have to apply longest mask matching. That means you will make a match with longest mask first. That is the basic thing. Okay, and in GATE exam they have asked such questions. You can check it out with from previous year questions. They will keep them in increasing order just to confuse you. Okay, so do not worry. You simply apply the longest mask first. That is longest mask matching technique. Okay, so take the snapshot. I will jump to the next slide, and in the next slide I will put this point more precisely. Take the snapshot. Okay, so next I'm telling you, okay, so in GATE, if they keep net mask in ascending order, net mask in ASC means ascending order, even then apply longest mask first. Okay, so you have to apply longest mask first. So do not apply shortest mask first, because if you apply shortest mask is /0 only. So /0 everything will be forwarded to port number 3. That is not the case. Okay, so in GATE, if they keep net mask in ascending order, even then apply longest mask first. That is the basic rule which you have to follow. And in many questions, GATE exam has done these tricks. Okay, they have keep these tricks just to confuse the students. They will simply apply net mask if 0 is there, so they will simply apply 0 first, and they will find net mask is this. Obviously they will get net mask this only because you have applied 0. Okay, and they will forward the packet with port number 3, every packet, but that is not the case. Okay, so even if they keep net mask in ascending order, even then you will apply the longest mask first. That is the basic rule which you should remember. Okay, so I hope you have got the idea. Take the snapshot. I will jump to the next slide. Okay, so this is all about your routing table concept. Okay, so now I think you have got the idea how we will fill this table, and the next is how you will forward the packet. Both we have covered. These type of questions are very important, and many times questions have been asked. So you should remember this thing. Okay, next is another beautiful numerical which have been asked in GATE. So from where we started with root method. Okay, and that was very worst idea. Then we jump to next hop method, then we jump to network specific method, and then we jump to default method. Okay, but in default method also there might be many entries. For example, let me tell you that. Take the snapshot. Okay, you have taken it already. Yeah. So what I will say, if we have a very big network of say 700 routers. So directly and indirectly there are 700 networks, and we have made.
You are currently the only person in this conference.
Yes, I am audible. Please let me know. I think my internet connection was gone. I think my internet connection was gone. I am audible now.
Yes, even my voice was not coming. I had to rejoin.
Okay. Yeah, so I was telling you that we have to start now hierarchical routing. Okay, so what is hierarchical routing? Hierarchical routing means, for example, we have a very big network in which we have say 700 routers. Okay, so now each router will have to keep entry of all other routers now, including itself. Okay, so this router will have to make 700 entries. 700 entries. Even if you are using default method, but what is the use of default method here? Okay, because you have to keep all the routers entries na. Okay, because this router is connected with all these 700 routers. Okay, yeah, so 700 entry with each router, and the total there are 700 routers, so 700 into 700, so it comes out to be 4,90,000 entries total. These much entries you have to keep. Okay, now it is not economical. Okay, because 4,90,000 total entries now in each router 700 entries, so total entries will be 700 routers into 700 entries, that is 4,90,000. So now I want to decrease the size, okay, or I want to decrease the number of entries. Okay, so for that what we will use, there are many terminology which we can use. For example, one of the terminology is we can make set of 10 routers each and make one region. Okay, so for example, I will make one region is equal to 10 routers. Okay, so 10 routers you will keep and you will make one region, that is R1 region. Next 10 routers entries, R2 region, and so on. So how many regions will be there? 700 divided by 10, that is 70 regions will be there. Okay,
it's not like
so
49 lakhs, 4,90,000. So it's
total number of entries.
700 entries in each router. 700 entries.
Each router, and total 700 routers are there. So number of routers and number of entries in each router. 4,90,000 total entries are there. So now what I am saying, one region 10 routers. So total R1, R2 up to R70. Total 70 you can say regions will be there. So each router will have to make how many entries? So 10 entries for its region, and next 69 for other 69 regions. Are you getting it? This router will keep entry of itself also and 9 routers more. So total 10 entries for this region only. Okay, each router. Okay, so for example, this is a X router. So X router, what it will do? It will make 10 entries, including itself, for its region, and next 69 entries each for one of the region. Are you getting it? Okay, so now no need to keep all entries. Okay, so you will keep just one. More precisely, I will say just you take one router as a representative of this region, and you will keep entry for that router only, whatever is the representative of that region. Okay, so politics is done like this only, na? So there is only one head, this for which we call it as Jila head, or you can say city head. Okay, so like that. So he is the representative of this entire region. So you will keep one entry for this. So total number of entries will be how many? 79 entries. And there are how many routers? 700 routers. So total number of entries 700 into 79. Earlier there was 700, but now it is 79. Huge decrease. Okay. So now in the same way, we can make a multi-level hierarchy also. This is one hierarchy, that means we have regions. Then we can make clusters also. Okay, for example, I can say with say 5 regions, we will make one cluster. Okay, so 2-level hierarchy. 2-level hierarchy. I will say 10 routers, we will make one region. 10 router will make one region, and 5 regions you will make one cluster. Okay, and for calculation easiness, take 10 regions. 10 region, one cluster. Okay, so now how many entries will be there? So what I want to say is, directly, indirectly, I want to say is, so total 10 routers, this is one region. And how many regions we are taking? Total 10 regions we are taking, are 10 regions, and you are making this as one cluster.
Yes.
Okay, so this is a cluster number 1. So now imagine how many entries for this router. Say this is router X. This router X will keep how many entries? This router X will keep, see, total 10 entries for its region. 10 for its region, because including itself, it will make entry for all the routers. Then 9 for other regions in this cluster, plus 9 for other regions. The 10 for the given region and 9 for other regions. Let me write it properly. For other regions. For other regions. Okay, and then how many entries? How many clusters will be there? So see this, total 10 routers, one region, and total 10 region, one cluster. So total 100 routers in one cluster. So total 7 cluster will be there.
Yes.
Any doubt here?
No.
So 7 cluster will be there. So 6 cluster entry you will make. So 6 cluster entry. So how many entries? So 10 plus 9 plus 6, 25 entries. So total entries is 25 entries. And there are 700 routers. So now you need only 700 into 25 entries. So simple. So see this, initially there was 700 into 700. Then with 2-level hierarchy we get 700 into 79. Then with 3-level hierarchy we get 2-level hierarchy we get 700 into 25 entries. Okay, so like that we can increase number of levels, and it is not standard terminology like region, cluster, and so on. One time question I have been asked in GATE, so I have given you the same thing, that is region and cluster. Okay, so you can make your terminology and they can give their terminology also. It hardly matters. So I hope you have got the point.
Understood, sir.
Okay, take the snapshot, then I will solve the GATE question which has been asked. Done? Okay. So the question is, we have total 40, I will write in the shortcut manner. So there are 4800 routers. 4800 routers in the network. So network is very big. Okay. So which region and cluster site should be chosen? Which region and cluster size should be chosen? Okay, so A option is So I will write it like this just to save the time. Cluster, region, and routers. So they are saying first option is 10 cluster you make, and in each cluster you have 24 region, and each region will have 20 routers. So first of all, you have to do the calculations. Is it okay or not? So 10 clusters, 24 regions. So 240 into 20, that is 4800. Yes, 4800 routers total. So this is good. A option might be okay. Sometimes this calculation itself will fail, so you will cut that option directly. Are you getting it?
So router into regions 20 to 24 and then 10 clusters. So
you can take anyway. 10 clusters are there. Each cluster is having 24 region, and each region is having 20 routers.
4800. Yes,
Please come again.
I got it, sir. Yes, sir.
Okay, okay. Yes, okay. So B option is, so they are saying 12 clusters, 20 region, and then 20 routers. C option is 16 clusters, 12 region, 25 routers. D option is 15 clusters, 16 region, 20 routers. So let me check one by one. We will check that out. Okay. So number of entries for the cluster will be 9, 23 for region, and 20 for the router. So how many entries? 20 plus 23 plus 9. You can add them up. Each router will have to do these many entries. So in the next case, 11, 19, and 20. So what you will have to do, 20 plus 19 plus 11. In the next case, then I will write now shortly. So 15 plus 11 plus 25. Here 14 plus 15 plus 20. Now you add them, whichever is minimum, that is the answer. So simple. Okay, so 43 plus 9, 52. Yes, here. So 19 plus 11, 50. Okay. And what about this? 25, 35, 40, 51. And here 35, 49.
49, sir.
D option is correct. Now, but before checking 49, you have to do the calculation. Is it okay or not? 15 into 16 into 20. Please do it. 15 into 16 into 20. You should get 4800. If you are not getting, then it is wrong. It's as simple as that.
We got 4800, sir.
Yeah, so that's it. So D option is correct. Okay. But if by chance you are not getting 4800, you will cross that option. You will say calculation is not good. Okay. So you will check next other option and so on. Okay. Yes. So you can take snapshot of this. I will jump to the next slide.
Done, sir.
Okay. So this is hierarchical routing.
4800 on this.
Yeah, please come again.
All the options, their product is 4800 on this.
Yeah. Yes. If by chance, I'm saying by chance, they can twist the question little bit. Okay. So you might take a smallest answer, but the calculation mistake might be there. So you have to cut that option. Okay. So idea is how you will approach such question. You just find the minimum, and after finding minimum, just do one-time calculation so that you get the exact answer. Okay. Otherwise, they might do some calculation mistake. For example, here they give 15. Then it is not possible. Now 15 clusters, 15 region, and each having 20 routers. Obviously, it will not make up to 4800. Okay. Yes, so it will be rather 4500. Na? 15 into 15, 2 to 5 into this 4500. So 4500 is wrong. Okay. So no doubt entries will be less. But what is the use when we are not able to cooperate with 4800 routers? So D option will be wrong. Then you have to check other options. Okay. So take the snapshot. I will jump to the next slide. Okay. So hierarchical routing was one of the way to decrease the number of entries further. Our aim is to decrease the number of entries as much as we can. Okay. So next way is geographical routing. Next way is geographical routing. So geographical routing means you will take a very big, you can say, you can say what we call it as what we call that.
The land area, sir?
No, no, no.
Boundary.
Routers, the IP address cluster. You take a very big.
Topology.
No, no, a very big cluster you take, okay, and you give that to one geographical area. Okay, so what we will do, for example, we take say 140.0.0.0/8. Just for the sake of example, I really don't know what is happening and what is not. I'm just telling you just for the sake of example. So I have taken a large chunk of IP address or large block of this IP address. How many IP addresses are there? 2 power 32 minus 8. That is 2 power 24. That means 16 million. So these I will give to US. Okay, so that means whenever IP address start with 140, you will say, okay, this is for US. For example, STD codes like 011, this is for Delhi. So as soon as you find 011, you will say, okay, this is Delhi. 022, okay, it is Bombay, Mumbai, and so on like this. Okay, so this has been done practically, but I am not showing you the exactly what is the number given to US and so on. It is not required for GATE. They will not ask which number is given to US, which number is given to India, and so on. So I'm just telling you the idea that from the first octet itself, we will come to know that this IP address belong to which country. If you have used VPN, virtual private network, or something like that, you have got it, na? So you will get an IP address from say Argentina or from US, okay, or from Canada. So how they will simply change your IP address to the IP address which belong to Canada, like that. Okay, yeah. So and you can imagine, for example, say 10.40, okay, or 100.40.0.0/16. This is given to India. Okay, so the moment you find first block as 100, you will say, okay, this IP address belong to India, and so on, like that. Okay, so there are many things which we have to consider. So this is known as geographical routing. Okay, so we have divided our entire address space into few large blocks. Okay, and each block is assigned to each continent, like that. If you want to write, then you can write one line. So we have divided the entire address space. We have divided the entire address space into few large blocks. We have divided the entire address space into few large blocks, and each block is assigned to each continent. And each block is assigned to each continent, then country, and so on. Okay. Okay. So now what is the use? So now in USA, for each and every computer in India, they will keep only one entry, that is 140.0.0/16. This is the beauty. So in India, routers or outside US, just forget about India, outside US, each and every router will have just one entry, that is mask. I have told you 4 entries, na? Mask. What was that? Mask, net ID, next hop, and mask, net ID, next hop, and then port. Okay, so mask will be /8. Okay, net ID will be this 140.0.0.0. Next hop will be whatever is your ISP router. Okay, ISP router. Okay, and port will be whatever port it wants. You keep port 3, 4, whatever is that only. So only one entry. Okay, so each and every router is having just one entry for entire USA. Okay, so this is the beauty of geographical routing. So this is how we have decreased the number of entries in the routing table.
It is like the class we studied, no sir, the net ID and the host ID has been separated.
Yes, we can think like that. Yes. Okay. So now everything is over. We have got the exact clarity about net ID and all. Now question arises how you will fill this routing table, or how router fill the routing table. That is the basic scenario now. Let's take the snapshot. I will jump to the next slide. So now what is the question in our mind? We come to know about this routing table and so on, and I have solved questions also. Obviously now we are doing manual entries. Is manual possible for in internet? No, not at all. There are many routers. How you will keep a record of all these things? Okay, so now question arises how to fill the table. How to fill routing table, or you can say how router fill the routing table, because manual is not possible. Okay, so but just for the sake of completion, I will write there are two ways to fill the routing table, that is static, or you can say static routing table or dynamic routing table. Okay, static means a network administrator will fill the table, but it is not at all possible now. Network administrator fill the table, but not possible. Okay, dynamic, now it is possible. That means router will fill the table themselves. Okay, so router will fill the table. Router will fill the table. That is dynamic routing table. Okay, yes. So how router will fill the table? For that we have different routing algorithms. Different routing algorithms. Okay, so you can take the snapshot. In the next slide we will start these routing algorithms.
Done, sir.
Okay, so broadly, if we talk broadly, routing algorithms are of three types. Routing algorithms are of three types. The first is adaptive routing. Adaptive. Next is non-adaptive. And the last is broadcasting algorithms. Okay, so there are three types of routing algorithms: adaptive, non-adaptive, and broadcasting. Adaptive is of four types. You just have to remember their names. We will not dig deep into that because we will study only two routing algorithms which are in our syllabus. In GATE syllabus we have only two: DVR and LSR, distance vector routing and link state routing. Only two are there in GATE syllabus. But still I am giving you the entire chart because they can ask which of the following is broadcasting. Rather they have asked in MSQ, they have asked which of the following is broadcasting algorithm. Okay, which of the following is adaptive algorithm, like this. Okay, so you should know this chart properly. Okay, so try to follow it. So adaptive, there are four types. One is centralized, then isolated, then distributive, and then delta. Okay, so total we have four types of adaptive routing algorithms. Next is non-adaptive. Okay, so actually it will mess up all the things. So one by one we will start. So first of all, I should tell you about what is adaptive. What do you mean by adaptive algorithms? Adaptive means they can adapt with the environment. For example, we have adaptive, non-adaptive animals are there, na? Okay, warm-blooded, cold-blooded. It is just like that. Adaptive means which can adapt to the changing environment. For example, humans are hot-blooded animals. We can adapt with the changing environment. But crocodiles, they cannot match with the changing environment. Okay, they have to hibernate and so on. So adaptive means they can adapt with changes. That means, see this. Router will obviously, routing algorithm means what? We are now router will fill the table automatically. That means they will fill themselves. But after filling, if one of the router fail or some route is congested, then they will change their routing table. That means they will adapt to the changes. That is the basic meaning of adaptive. Okay, adaptive means if one router fail or something has been done, they will adapt to the changes. So I will simply write one word: adapt to change. Adapt to change. Non-adaptive means they will not adapt. Okay, that means they will fill the table only once. Router will fill the table only once. If router fail or something happened, they will not going to change them. Okay, non-adaptive means not adapt to change. Not adapt to change. Broadcasting, they can be either adaptive or they can be either non-adaptive. There are two categories of further broadcasting. Okay, so one by one we will start. Okay, so the very first is centralized. Okay, centralized. As the name suggests, what do you mean by centralized? Just one line. Centralized means everything is centralized now. So there will be a centralized router, which is, I have designed it very big. It is a very big router, that is centralized router, and there are multiple small routers. Okay, so whenever packet arrives to these small routers, they will first consult this big router. And this big router is having entire routing table and it has entire idea of the network and so on. And these small routers do not have idea. Okay, so what they will do whenever they receive a packet, or they will first ask this router where to forward this packet. So this router will give the reply, okay, you can forward it to here and there and so on. So accordingly they will forward. Okay, so they can keep entry for say 30 seconds, 1 minute or 10 minutes or 1 hour, depending upon the situation to situation. They can keep the entry, but the basic fact is that all the entries will be here only. Okay, these routers, these secondary routers are not storing it. Primary router is storing the entries. Secondary router is not storing the entries. Okay, they do not have idea about the network or something like that. The primary router has the entire idea. Okay, yes. So what is the disadvantage here? Single point of failure. If this router fail, primary router fail, everything goes down. And what is the advantage? Number of entries will be very less, because now these routers are not keeping the entry. Only this router is keeping the entries. Okay, so advantage will be number of entries less. Okay, disadvantage, single point of failure. Single point of failure. Single point of failure. Okay, that is centralized approach. And example of centralized approach is path vector routing, PVR. They will ask you, PVR is centralized, isolated, or so on. So PVR is centralized. PVR is path vector routing. Path vector routing. Okay, yes. Next is isolated. Isolated is again of two types. One is known as
centralized, no, sir?
Path vector routing is centralized. Example I have given you. Okay, so next is isolated. So let me jump to the next slide, because this slide will be very messy. Take the snapshot of this.
Done, sir.
Okay, isolated. Isolated is of two types. One is known as hot potato routing, and another is known as backward learning. Hot potato and backward learning. Hot potato, as the name suggests, see, actually each router has say 4 ports. So with each port there is a queue associated with a queue associated of the packets. Router speed is very high. It can forward the packet. Okay, but this bandwidth at this port is very less. So obviously router will keep the packet in the ports. In the queue. Okay, so there will be queue of packet attached with each port. Okay, as the name says, hot potato means if somebody keep hot potato on your hand, what you will say? You will just try to get rid of it. That is the scenario here. So this router will try to get rid of the packet as soon as possible. So forget about where it was going, from where it was coming. Without any analysis, router will keep the packet in the smallest possible queue, so that it can get rid of the packet as soon as possible. This is known as hot potato routing. So now you may argue, sir, how packet will be forwarded and so on. So it is very densely packed network. So from where we have path from one node to another node. For example, see this, just like imagine a complete graph of 4 vertices. Okay, so for example, you are here, okay, and you want to send packet to B. So it hardly matters whether you forward packet here, here, or here. Finally, it will reach B by hook or by crook. So in that scenario, I can use hot potato. Okay, so hot potato means place the packet in the smallest queue. Just write one line. Hot potato means. Okay, you have written that. Okay, it's good. Yes. Next is backward learning. What is backward learning? So backward learning is say, for example, this is a source. Okay, this is a R1, R2, and R3. Okay, so what we will say? So we can have a field called hop count in IP header. Okay, so now this hop count will keep on incrementing as it moves from one router to another. So R3 will see that a packet has come from the source. Okay, and let us suppose this is port number, say, R3, and this is port number 1. Okay, so R3 has received a packet from source. Okay, and it is saying that it has come from port number 1. Okay, so for example, S to R1, R1 to R2, and R2 has forwarded the packet to R3. R3 has received from S, port was 1, and hop count will be say 2. So R3 will say, okay, between me and S two hops are there, and S is connected with port number 1. Are you getting it? So here this router is learning from the packet movements. So this so the source can be any IP address, any packet, any, you can say, computer which has sent the packet. So this computer might having some IP address. So this R3 will keep that entry. Okay, it will say that S is connected to me with port number 1 and number of hops in between are 2, like this. Okay. So this is known as backward learning. As there is a backward learning, from backward you are learning. From backward means what? You are not learning from destination. You are learning from the source. SIP, DIP, two fields are there, na? Okay. So SIP means from source IP address you are learning. You are not learning from destination. Why you are not learning from destination? Because destination might be any IP address. R2 can send the packet with same DIP. R1 can send a packet with same DIP. S can send packet with same DIP, and so on. Okay. So destination might be same, but source are these, na? Are you getting it? So learning is always done from source. You should know this fact. Learning is always done from source. Okay, this is the basic fact here. Anyhow, I am not going into that much detail. This is much more extra which I have told you. Okay, so you should know this fact only, that backward learning is a type of isolated. Okay, and I think you have got it. Why we are calling them as isolated? Because if you say that this person is isolated, that means what? This person is having very high ego. He is not ready to learn from neighbors, and the neighbors have just isolated him. That is the basic meaning of isolated. That means these routers are not seeking help from other routers or from other neighbors. They are having very high ego. They will say we will learn by themselves. We will not seek help from others. So directly, indirectly, they will learn from packet movements. Like here, with whatever we are here, we are not learning. Here we are just forwarding the packet. Okay, that is isolated. Isolated means you will not take help from neighbor. But what if you take help from neighbor? Neighbor already have very high information. You already have very high information. If you collaborate, then obviously you will get a lot of information about the network. Okay, so that is the better way, and this is known as distributed approach, which is our next approach. This is distributed approach. Okay, yeah. So you can take snapshot of this. I will jump to the next slide. Okay. So distributed approach, what it is saying? Distributive approach. What it is saying? It is saying that learning from neighbors. Learning from neighbors. Okay, that is much better idea. But what isolated was saying? Isolated was saying learn from packet movement. Do not learn from neighbor. You are isolated one. So isolated means learn from packet movement. Learn from packet movement. Okay. So distributed, we have two types of distributive. Rather, there are many approaches, but two are very famous. One is DVR and one is LSR. Distance vector routing and link state routing. That's what we have to study for GATE exam properly. We will study these two properly. Okay, so this is all about distributive. Next is delta approach. Take the snapshot. Okay, I will write it here itself, delta. I will just tell you one line. We will not dig deep into it. Delta is hybrid. Hybrid of centralized and isolated. Hybrid of centralized and isolated. Okay, so we have clubbed these two techniques to get the delta routing. So I think you have got it. Now this is the last one, delta. Delta is hybrid of centralized and isolated. Centralized and isolated. Mixture is delta. Okay. So next we are going to start is non-adaptive routing. Okay, so next is non-adaptive. Non-adaptive is of three types: flooding, random walk, and multipath. Just try to remember the names only. Flooding, as the name says, flood comes, then water will see that it's your house, I will not come here, and it's their house, I will go there. No, water will not see anything. It will simply flood into each and every house. That is the basic meaning of flooding. Flooding means whenever router receives a packet, it will forward to all the ports, So except incoming. Of course, router has this much common sense that I have received packet from this port. I should not forward the packet from this port because I have just received it. So I will forward it to all the ports except incoming. That is known as flooding.
Not possible in reverse direction.
Yeah. So please write down, as the name suggests, every incoming packet is sent to every outgoing line except the one on which it arrives. As the name suggests, every incoming packet is sent on every outgoing line. Every incoming packet is sent to every outgoing line except the one on which it arrives. Except the one on which it arrives.
Sir.
Okay. So what do you think that why flooding is used? Okay, so obviously traffic will be very high in the network. Unnecessary you are forwarding packets to each and every port. Okay, for example, this was some router here and this was computer A here. Okay, B want to send message to A. Now you have unnecessary forward here also. Why you have forwarded it? Okay, so the basic idea, no doubt traffic will be very high, but it is used where we need very high robustness. Robustness means, like for example, military environment. Okay, so if you can say if this path is broken, then so A will never receive the message. Okay, so better is you forward everywhere. So somewhere I think there might be a path which can lead to A and so on. So if you want to send a very important message and you want that by hook or by crook it should reach the destination, then flooding is the best way. Okay. And another reason is it will guarantee shortest path. That means presently shortest path, whatever will be the shortest path, A will receive the packet from that path. No doubt A will receive multiple packets, duplicate packets it will receive because see this router has created 3 duplicate packets. Okay, and it has forwarded these duplicate packets to these 3 ports. Now whatever will be the shortest path, I really don't know at present. Whatever is the shortest path, from that path A will receive the packet. So that directly and indirectly I want to say fastest delivery is guaranteed by flooding. Are you getting it?
Yes, sir.
Okay, so please write disadvantages, traffic will be very high in the network. Disadvantage, traffic will be very high in the network. Advantages, it guarantees shortest path. It guarantees shortest path, and it provides high degree of robustness. And it provides high degree of robustness. Mainly used in military networks. Mainly used in military networks. Okay, this is all about flooding. Next is random walk. Random walk, as the name says, randomly you will walk. So it is non-adaptive version of hot potato. Hot potato was adaptive, na? So this is non-adaptive. Non-adaptive version of hot potato. Okay. Yes. Next is multipath. Multipath is non-adaptive version of delta routing. Non-adaptive version of delta routing. Actually, these algorithms are very big. Okay, if you dig deep, then for delta routing you have entire book written for delta routing, how this will work and so on. You have 1000 pages book for these algorithms. Okay, so we really don't know these, don't need these kinds of thing. I'm just giving you one line idea. So that in worst case, if they ask, they will ask this thing only. What is multipath? Multipath is non-adaptive. Okay, and it is more non-adaptive version of delta routing. Like this, they will ask. Okay, so no need to dig deep into the things and so on. More than sufficient, whatever I'm telling you. Okay. So this is all about non-adaptive. Last is broadcasting. Let me jump to that. Take snapshot. Okay. Next is broadcasting. I think one broadcasting I have already done. That is flooding. Flooding, I think you have got it. It has broadcasted. Okay. So one is flooding. Flooding is broadcasted algorithm, and it is adaptive or non-adaptive. I just told you non-adaptive.
It is non-adaptive.
I have just told you. Okay. Next is multi-destination. Multi-destination. Next is spanning tree, and next is reverse path. Okay. So and these three can be adaptive as well as non-adaptive. Whatever way you want, you can make them. These are just approaches. Okay. So these approaches can be adaptive or non-adaptive, but flooding is for sure non-adaptive. Okay, so now before studying these, because there is a need of spanning tree here, let me tell you few basic points about a few more points about flooding. So a very big problem in flooding is, see this. So here A is connected, and suppose here B is connected. So A want to send packet to B, so this router will forward packet here as well as here. This router will forward packet. Of course, it will not send to incoming port. It will send here. This router will send here. So there will be a loop like this. So we want to get out of loop, because if the loop is there, then obviously packet will keep on forwarding and so on. There will be a problem. So I have told you one approach to avoid this loop. I think you already know TTL field, time to live field.
Yes, sir.
Okay. So I have covered that also. So this is also one of the solution. Okay. So flooding is it can lead to loop problem. Flooding can lead to loop problem. Okay. Yeah. So there are three solutions to to avoid this loop problem. One is sequence number. Next is hop count. And the next is spanning tree. This one. Spanning tree. Sequence number, as the name suggests, each packet will have a sequence number. When router forward the packet, it will note down its sequence number. So when this router again receives the same packet, that means with the same sequence number, it will drop the packet saying that I have already forwarded it. So every router will do just one task. Okay, it will say I have forwarded the packet. That's it. I will not going to forward it again and again. So how it will keep the track? That for that we have a sequence number. So each packet has a unique sequence number. Each packet has unique sequence number. Okay. So when router receives the packet, it will note down the sequence number. And when the same sequence number packet again arrives at the router, it will simply drop it saying that the same sequence number I have already forwarded. I'm not going to forward it again. So obviously loop will be avoided. Next is hop count. Hop count is just like TTL, time to live. Okay, it will be decremented on each hop. The moment it becomes 0, it will be dropped. Okay, decremented at each hop.
Yes, sir.
Decremented at each hop. 0 means drop. Roughly I'm writing because I have already told you. Next is spanning tree. Spanning tree is also very easy. So what we will say, I think you have studied algorithms now. You have studied about minimum spanning tree and all.
Yes, sir.
Prim's Kruskal and so on you have studied. So now it's very easy for me. So I will say, for example, this is the network like this. Okay, so we will make a MST kind of thing, minimum spanning tree. And for example, I will say that I will keep this and this. Rest I will delete. This I will delete. This I will delete. And say this I will delete. Okay, and finally what we have got is MST. So obviously the minimum spanning tree means what? No loop. No loop means what? So obviously how you will get a loop, because this router is connected with this only. So whenever this router receives a packet, it will not forward anywhere. Yes. Okay, so no doubt we lines are there. Okay, lines are there, but they will not forward them. So directly I want to say the ports will be disabled. Okay, so ports of the router will be disabled. Ports of routers will be disabled Okay, ports of the routers will be disabled. Okay, and to make spanning tree. To make spanning tree. Any doubt here?
No, sir.
Okay, so that's it. This is all about the three possibilities. Next is multi-destination. Multi-destination, as the name suggests, it is used in multicasting. It is not in our syllabus, so we can skip that comfortably. But in just one line, if you want to say, then I can say like this. So in multicasting, obviously that's the destination IP address. It is not unique. There will be multiple IP addresses because multiple stations want to receive the packet. Okay, so so for example, this router has got a packet which is having multicast address. Okay, and it is having, say, these many ports. So it will forward, depending upon the address, it will make copy of the packet and it will forward till here. It will not forward here because not needed. So now here we have a router. Again, it will forward here, and we have a router here. It will forward here. We have a router. It will forward here. We have a router. It will forward here, and so on. Ultimately, it will reach the destination. Okay, all the destinations whatever we want. So this is known as multi-destination. Any doubt here?
No, sir.
Okay, so roughly I have just told you, I have just given you idea. Spanning tree I have already covered. What is spanning tree and all? Okay, last is reverse path. Okay, reverse path is same which I have told you. Okay, so that means okay, so take the snapshot. I will jump to the next slide.
Done, sir.
So in reverse path, what we will say, this is a router. Okay, so this is the port number 1, port number 2, port number 3, port number 4. There are 4 ports. From port number 2 there is another router connected, here also, say here also, and so on. Like this we have a network. Okay, so now it will whenever packet comes to this network, to this router, it will check SIP. Okay, and according to SIP, it will check whether the packet arrives on this line normally or it has arrived from some other path. Okay, for example, from port number 1, it has received the packet, and SIP was something like XYZ and so on, XYZW. This is IP address. From port number 1, it has received, router has received this packet. Now it will check from the routing table whether this XYZW packet comes from port number 1 or some other port normally. Okay, so if it say that normally it comes from port number 1, then it will forward. If they say that it has normally it comes from port number 3, but now it has come from port number 1, so directly and indirectly it means, okay, somebody has forwarded it and I have got it. I have not got the actual packet, I have got a forwarded packet, so I will drop the packet. Okay, this is reverse path forwarding. And name itself suggests reverse path forwarding. Reverse path. So you are checking the reverse path. Okay, so it will check whether the packet come from here normally or not. If normally, then it will forward. If normally it is not coming from this port, normally it comes from port number 3, but now it has come from port number 1. So directly and indirectly from here, it has got the packet. Okay, like this. So this is all about your reverse path forwarding. You should know the name only. Reverse path forwarding is one of the broadcasting algorithm. That's it. Okay.
Yes, sir.
That's it. So now you can take the snapshot. I will jump to the next slide.
Done, sir.
Okay. So now another category of routing algorithm is inter-domain versus intra-domain. Inter-domain versus intra-domain. Okay, so domain here means autonomous system. Domain here means autonomous system. What is autonomous system? Autonomous system is a network owned by an individual. Network owned by some company, you can say like this, some company. For example, autonomous system is Airtel in India. Okay, BSNL. Then is your Jio. These all are autonomous systems. Okay, so it is a large network owned by some company. Okay, so if protocol is working inside the autonomous system, then obviously we call it as intra-domain. And if it is used to connect two or more autonomous systems, then we will call it as inter-domain. I think you have heard the word, na? Intra and inter. Same. Okay, so intra means protocol working inside autonomous system. Okay, protocol inside the net, inside the autonomous system, working inside autonomous system. Okay, and inter means it is used to connect two or more autonomous systems. Okay, so finally we have got the idea about inter and intra. Take the snapshot. I will jump to the next slide.
Done, sir.
Okay, so now obviously routing algorithms are of two types. One is known as intra-domain and another is known as inter-domain. Intra-domain is of multiple types there are, but only two, DVR and LSR. So they will ask you properly, DVR and LSR are distributive routing algorithms and that too intra-domain. Okay, DVR and LSR are distributive routing algorithms. Now I have just told you, and they are adaptive. So basically you should know these 3 points. DVR and LSR, they are adaptive. That means change. They can change with environment. If one router fail or something, they will change the entry, and I will tell you how they change and so on. Adaptive. Second is distributive, and the third is they work for intra-domain. These 3 points you should remember. Okay, inter-domain example is PVR, path vector routing. I have already told you, path vector routing, PVR. Okay, centralized approach, no? Centralized.
Yes, sir.
Okay. Yes, and let me tell you these basic things also. So DVR is based on Bellman-Ford algorithm, which you have studied in your algorithms. Bellman-Ford algorithm. Link state routing is based on Dijkstra's algorithm. Someone calls them as Dijkstra. It is not Dijkstra, it is Dijkstra's. Dijkstra's algorithm.
Vivek sir told us that.
Please come again.
Vivek sir explained that it is Dijkstra. It's not Dijkstra or something.
Okay, yes. So yeah, so Bellman-Ford algorithm, it is based on Bellman-Ford and it is based on Dijkstra's algorithm. And if I talk about protocol on DVR is an approach. On this approach, we have one algorithm, one routing protocol, that is RIP, routing information protocol. Okay, RIP is routing information protocol. They will clearly ask you, RIP is based on DVR, distance vector routing. And on LSR, one algorithm is OSPF. I am telling you all MSQ questions, multi-select questions. OSPF, open shortest path first. OSPF is open shortest path first. Okay, so it is based on LSR, link state routing. Link state routing is an approach. This approach is used in this protocol, open shortest path first. Okay, open shortest path first.
LSR abbreviation, so?
Link state routing. Link state routing.
Done.
Okay, so PVR, on PVR we have one algorithm, one protocol, that is BGP, border gateway protocol. Border gateway protocol. Okay.
Yes, sir.
Okay, so that's it. So now we will start our first important algorithm, that is DVR, or distance vector routing. So you can take the snapshot of this. I will jump to the next slide.
Done, sir.
Okay. DVR or distance vector routing. So we have certain assumptions which we should know properly. So first assumption is initially every station or every router has idea about total number of router in the system. Please write down, these are very important assumptions because they can ask these assumption in MSQ also, and they will confuse you after a few slides. So better is you should write them. First assumptions I am telling you what DVR is assuming. First assumption is initially every station has, or every router you should write, initially every router has idea about total number of router in the system. Initially every router has idea about total number of routers in the system. Total number of router in the system. Okay. Next, weight on the edge. We will use some weight and so on. So weight on the edge can be distance. Weight on the edge can be distance or number of hops between them. Number of hops between them. Routing table has only 3 columns. Next is routing table will have only 3 columns. That is to, coast, next. Okay.
Yeah, to, host and next.
To, coast and next.
Okay.
Only 3 columns. So now let me start it. So I will make a small network. For example, this is the network containing 4 routers. So let's suppose this is router D, this is A, this is B, and this is C. So cost of this is 11, this is 7. So this 11 can be distance, or this 11 can be number of hops between C and D routers.
Yes.
7, 3, 2, 1. Okay. So now I will tell you how routing table will be constructed. So I will write here A table. It will contain 3 columns. To, coast, and next. So I will write everything to A, B, C, D. This is always sorted. Okay, A, B, C, D. So A, B, C, D like this. So everywhere it will be A, B, C, D only. I will tell you reason that why it is sorted and all. So but first of all we will write it A, B, C, D. Then coast. A to A, coast obviously 0. What is the next hop? Next hop is A. A to A, we will just assume it like this. Okay, A to A. Okay, next to B. Coast is 2, next is B only. Okay, next is B. C.
Coast also?
Coast 2. A to B, 2, 2.
How do we know it is A to B? So 2, because it is in the 2 and we go in order A to B. Yes, sir.
Acha. Okay, so I think I'm making this A table.
Right. Sir.
Okay, so I will say A to B. Coast is 2 and next is B. Okay, now A to C. A to C. So there is no direct line. So it will say initially infinity. Next is nothing. It does not know about anything about C. But entry of C is there because I have told you an assumption that every station has idea about all other stations in the network. Okay. So that's why I have kept entry for C. Otherwise I have not kept this entry also. But I am keeping it because I already know number of routers in the network. D. What about D? Coast is 1. Infinity. And what is the next? D. A to D. Coast is 1 and the next is D only. So this is the table for A. Okay, I will copy it out. This is for B. Acha T nahi aaya. Okay, so I have kept it here. Yeah, so now I will keep on changing it. Okay, so this is D table. This is C table and this is B table. A, B, C, D, that is same only. So B to A to B, B to A cost. You will say B to A cost. B to A cost is 2. Next is A only. B to B cost is 0. Next is B only. B to C cost is 3. And next is C only. And B to D cost is 7. Next is D only. Any doubt?
No, sir. Understood.
Okay. So for C, C to A. C to A, infinity. Next, I do not know. C to B. Cost is 3. Next is B only. C to C. Cost is 0. Next is C only. C to D. Cost is 11. Next is D only. For D. D to A. Cost is 1. Next is A only. D to B. D to B. Cost is 7. Next is B only. D to C. D to C. Cost is 11. Next is C only. D to D. Cost is 0. Next is D only.
Yes.
Okay. Yes. So now what they will say, distance vector routing. First of all, you should know what is distance vector. What is distance vector? Distance vector is this. Vector means array. In computer science, it means array. Okay. So vector means array. Okay. Yes. So this is an array. Array of cost. So distance vector routing means each and every system will share this distance vector with all its neighbor. Okay. So you should know this fact. So each and every router will share distance vector with all its neighbors. I told you, learning from neighbor, distributive routing. So here we will learn from the neighbor. So they will exchange their knowledge with everyone. Okay. So now what I have told you, each and every router will share distance vector with all its neighbors. Okay, with all its neighbors. So please tell me, D will receive distance vector from how many? All of the neighbor A, B, and C. So A, B, C will send distance vector to D. A will receive distance vector from D and B only. C is not the neighbor. B will receive distance vector from C, D, and A, and C will receive distance vector from D and B. Okay. So and these distance vector, they will be exchanged parallelly. That means C is sending its distance vector to D and B, and similarly at the same time it is receiving distance vector from D, B, and so on. So full duplex mode we are working. Okay. So now what I will say, so we will have rounds. So there are total 4 routers. So we will have 3 rounds. I will give you reason for each and everything. Don't worry about it. Okay. So if we have n routers, there will be n-1 round. Let me tell you round by round what we are going to do. So in round number 1, each of these router will share their distance vector with all other routers. Take the snapshot. I will jump to the next slide. Or rather, I should copy this slide. It will be much more efficient. Duplicate. So now I am going to tell you about round 1. So here I will write it. Okay. So D will receive distance vector from A, B, and C. So from A, what it will receive? From A, what it will receive? 0 to infinity, 1. From B, what it will receive? 2037.
So who is receiving this?
D. D will receive distance vector from A, B, and C. In round 1, I am doing. In round 1, D will receive distance vector from these 3. C will receive from these 2, and so on. So and from C, what it will receive? Infinity 3 0 11. So now you have got the idea that why we have done this sorted. If we have done this sorted, then obviously we are just exchanging distance vector. So now D will come to know that from A to A cost is 0, from A to B cost is C. So this is B. How D will come to know that this entry is for B? Because we have done sorted everywhere. See this ABCD, 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 ABCD. Okay. So there is no confusion at all.
Yes.
Now what D will do? D will simply discard its table, and it will construct a new table. Okay, from which it will take the minimum values. Okay, so what D will make? To post next A B C D. Okay, and from here, from A this come, from B this come, and from C this come. So here you will write distance also. AD distance. AD is 1. BD distance is 7. CD distance is 11.
It is AD or DA, sir?
ADDA, whatever way you want, because it is not directed. Okay, so no problem. You can write any way. Okay, and if you are getting confused, no way, no problem. You can write DA, DB, or DC. No problem. Okay, because it is not directed. That's why. So now by common sense, what you will say? A to A cost is 0, but AD cost is 1, na? So D to A cost will become what? 0 plus 1, that is 1. Are you getting it?
Sir, I understand.
Similarly, I will say A to B cost is 2. A to B, see this, A to B cost is 2. But if AD cost is also added, then D to B cost will become 2 plus 1, that is 3.
So how?
Please try to understand it. No need to worry. I will repeat it again. I just want to say A has sent its distance vector to D. Now by common sense, you cannot use these entry as it is for D. D will add 1 to it. Why? Because A to D distance is 1. Are you getting it?
Sir.
So but same thing I have done. I am saying that from A to B distance is 2. Now from D to B distance 2 thodi hoga. We will add 1 to it, na?
A to
D to B?
A to B via D.
No, D to B via A.
Yes, sir. Yes, sir. Yes, sir.
You have got it? Okay. So finally, directly forget about proofs and all. I just want to say you just add this number with these all. Then calculate. It's as simple as that. So 0 plus 1, that is 1. Now 7 plus 2, that is 9. 11 plus infinity, that is infinity. Which is the smallest value? 1. So you will keep 1. And next, from where you have got this idea? From A you have got this idea. You will keep A here. So I'm preparing distance table for D.
Yes, sir.
Okay. So for B, what you will take? 2 plus 1, 3. 7 plus 0, 7. 11 plus 13, that is 14. Which is smaller? 2 plus 1, 3. So you'll keep 3 and via A. So you can check it out. D to B via A is 2 plus 1, that is 3.
Yes, sir.
Okay. So what I am saying is you have just sent this distance vector to D. So you cannot copy this same. You have to add 1 to it. So that you because every distance was from A. Now you want to check from D. So D to A distance is 1. So you have to add 1 na. Okay. So if you want more clarity, then I will say like this. Delhi to Bombay distance is say 1400 kilometer. Now A to D distance is say 200. Okay. So A can be say Agra. Agra to Delhi distance is 200. So what is Agra to Bombay distance? 1600 or not?
Yes, sir.
Okay, so Delhi has given information to Agra that you can reach Bombay in 1400 kilometers. But A have to consider that okay, from me to from Agra to Delhi distance is 200, so I have to add 200. So final total distance will be 1600. That is what we are doing here. Okay. Okay, so that's it. So now, I have just given you proof also. So now everything is fit and fine. Now you just add and get the answer. Infinity plus 1, that is infinity. 7 plus 3, that is 10. 11 plus 0, that is 11. So what is smallest? 7 plus 3, that is 10. So you will keep here 10. And from where you have got this idea? From B. You will keep B here. For D, 1 plus 1, 2. 7 plus 7, 14. And 11 plus 11, 22. What you will keep? You will keep nothing. You will keep 0 only, because D to D distance is 0 only. Okay. So do not forget it. So D to D, you just write 0 and here D. Okay. So please do not say, sir, minimum is 1 plus 1, 2, 14 and 22. Minimum is 2, so you keep 2. No, D to D distance 2. How you got 2? So if you keep, if you want to give more precise explanation, I will say like this: D to A is 1, A to D is 1. So total 1 plus 1, 2. This is 2 what you are thinking about. Okay. But it is wrong. Clearly it is wrong. Why you want to go to A and why you want to come back to D again? So it is 0. So we will keep 0 here. Okay. So now I will say about A. A will receive distance vector from which? From D and B. And now please do not say D will send its updated routing, updated distance vector. No, it will be used for round 2. I have told you parallelly they are exchanging. Parallelly means D has already sent this to A. Okay, so do not use this. Use this only. Okay, so D will send it. So I think I have not dictated. You can write it. Each and every router will send distance vector to all the neighbor parallelly.
Sir.
Okay, yes, parallelly.
Parallelly, I did not.
Okay, yes. So now I will make for A. So what distance from D? 1, 7, 11, 0. From B, B is 2037. Okay, yes. And now I will keep the coast thing. So A to D coast is 1. B to AB coast is 2. So now I will prepare fresh. It will discard it. It will make a fresh table. 2 coast next. A, B, C, D. Okay. So what it will say? A to A. First you should keep it. A to A coast is 0. No need to confusion. A only. Now to B. Here we have got 7. 7 plus 1, 8. And 0 plus 2, that is 2. So which is better? 2 is better. From where you have got this idea? B. So we'll write B. C. 11 plus 1, 12. 3 plus 2, 5. Which is better? 5 is better. So you, from where you have got this idea? B. So now you can check it out. From A to C, na? C earlier it was infinity, but now you have keep 5. From where? 2 to 3. 2 plus 3, 5 via B. And if you go via D, then obviously it will be 12. 12 is not better option. 5 is better. So now D. So 0 plus 1, 1. 7 plus 2, 9. Which is better? 1 is better. From where you have got this idea? D. So D to A directly connected. You already know. Yes, okay. 1. So this is the new table for A. Similarly, we will construct table for C as well as B. Okay. So C. So C will receive distance vector from D and B. What D will send? 1, 7, 11, 0. What B will send? 2037. Okay, so this will be CD. CD coast is 11. BC. BC coast is 3. Okay. So now it will make a new table. 2 coast next. So it will be A, B, C, D. So A. Okay, C to C first you put 0. Next will be C. Then we will start. For A, 11 plus 1, 12, 3 plus 2, 5. Which is better? 5 is better. Via B. B, 3 plus 0 is 3, 11 plus 7 is 18. Which is better? 3 is better. Via B. D, 11 and 10. Which is better? 10 is better. Via B. So C to A, we are taking 5 via B. You can check it out. It is better option. And C to B, we are taking 3 only. And C to D, now this is the beauty. C to D, 3 plus 7, that is 10.
Yes, sir.
Like this you will go. Okay. So next is for B. B will receive from where? It will receive from C. It will receive from D. And it will receive from A. 3. So I will copy this out. Anji. So from C it will receive infinity 3 0 11. From D it will receive 1 7 11 0. From A it will receive 0 2 infinity 1. Okay. Yes, and now here we will say 2 coast next. Okay. So A, B, C, D. Put the values here. BC coast 3. BD coast. We are making for B, na? So that's why BD and AB. BD coast 7. And AB coast. AB coast is 2. So now B to B you put 0 first. A. Infinity here we'll just leave it 8 and 2. Which is better? 2 via A. Okay. C. 3, 18 and infinity. So 3 is better via B. D. 11 plus 3. 15, 7 and 3. 3 is better via B. Okay. So this is the result of round 1. Okay. So now in the same way we will do round 2. In the same way we will do round 2 and then we will do round 3. Okay. And after that
B to D via A. We will not write A there in the last column, sir.
Okay, from A, no, from where we have got it, idea we have got it from A. Yeah, sorry for that. A we will write, yes. A. Idea we have got it from A, that's why we will keep A here. Okay, so that's it. So this is the result of round 1. You can take snapshot or something. So similarly, we have to do round 2, round 3. So for round 2, we will keep these as our final values. Okay. And then similarly, we will do round 3. After round 3, we will stop. Okay. No need to go further. Okay. And reason actually time is up now. I should not dig deep here because we will get we might get some confusions. So better is we should stop here itself. In the next lecture, we will come and start from here. We will do round 2, then we will do round 3, and it's better. It's homework. You can try yourself. It's not any technical thing. So you can make round 2 and then round 3. Okay, and try to figure out that why we do not need round 4. Okay, you might get the answer that why we do not need round 4. It's just a hint. Hint is round 1 means you have included only one node in between. In round 2 you will include 2 nodes. In round 3 you will include 3 nodes. Okay, so that means more than 3 nodes we do not want, or you can say edges also. In round 1 you have included 1 edge, then 2 edge, then 3 edge. More than 3 edge we do not need because 4 vertices are there. Shortest path will contain at most 3 edges. It cannot keep 4 or 5 edges. So that's why we are taking only 3 rounds. Okay, so in fourth round there will be no optimization, so we will stop here itself, and that is what Bellman-Ford algorithm says. Okay. Yes, so we will stop here itself. In the next class we will resume from here.
Done, sir.
Okay, okay then. Bye bye.
Right.
Okay, bye bye.